Hi all, welcome to our class. In this section, we can study a new topic. The name of the topic is probability. In 7th standard and 9th standard, we have studied the topic probability. So, first we have to study what is an experiment. An experiment means an operation which can produce some well-defined outcomes. An operation which produces some well-defined outcomes is known as experiment. Now, random experiment. Random experiment means in an experiment when repeated under identical conditions do not produce the same outcomes every time, but the outcomes in a trial is one of the several possible outcomes. So, random experiment means in an experiment when repeated under identical conditions do not produces the same outcomes every time, but the outcomes in a trial is one of the several possible outcomes. For example, tossing a coin. What are the outcomes? We will get either tail or head. These are the two possible outcomes. So we don't know which will come, either tail or heads will come. So a random experiment means when repeated under identical conditions do not produces the same outcomes every time, but the outcomes in a trial is one of the several possible outcomes. Another example, rolling a dice. We know in dice 1, 2, 3, 4, 5, 6 are marked. So these are the numbers marked in a dice. Rolling a dice. Sometimes one will get either 2 or 3, 4, 5, 6. Any number will get. So rolling a dice, another random experiment. So random experiment means in an experiment when repeated under identical conditions do not produces the same outcomes every time, but the outcomes in a trial is one of the several possible outcomes. Next one is sample space. What do you mean by sample space? Sample space, very important portion. Sample space. Sample space means set of all possible outcomes is known as sample space. Set of all possible outcomes in an experiment is known as sample space. In tossing a coin. Tossing a coin means tossing a coin. Let us write sample space of some experiments. First one, tossing a coin. We know either head or tail will come. So, tossing a coin, sample space is head, tail. Two outcomes, head and tail. Next one, tossing two coins. Tossing two coins. Tossing two coins means first one may come a head, second also head, H. Then first one head, second one tail, or first one tail, second one head, or both are tail. So these are the four outcomes. Both are heads, first one head, second is tail, first one tail, second head, and both are tail. So tossing two coins means there are four outcomes. So sample space S is equal to head, tail. Here sample space, set of all outcomes. Now tossing three coins. Tossing three coins, let us write the sample space. Both are heads. This is the first chance. Both are heads. Then first to head, then is tail. Then first head, second tail, third heads. Next one, first tail, other two are heads. Then first two tail, last one is heads. Then first tail, then heads, then tail. Then first head, other two tail, or all are tail. These are the outcomes. 1, 2, 3, 4, 5, 6, 7, 8 outcomes. So there are 8 outcomes. This is tossing 3 coins. Tossing 3 coins. This is tossing a coin. This is tossing 2 coins. Here 2 outcomes. here 4 outcomes, here 8 outcomes. So set of all possible outcomes is known as sample space. Here number of outcomes 2. Here number of outcomes 4. Here number of outcomes is equal to 8. We know in a coin there are 2 possibilities, head or tail. So total 2 possibilities, head or tail. Tossing a coin, number of outcomes we easily get. There are 2 possibilities tossing a coin. So 2 raised to 1. Here tossing 2 coins. 2 coins means there are 2 possibilities, either head or tail will come. So tossing 2 coins means there are 2 possibilities, head or tails, and we are tossing 2 coins or 2 times. A coin 2 times or tossing 2 coins, both are equal. Tossing 2 coins or a coin tossing 2 times, both are equal. So tossing 2 coins, actually 2 outcomes, head or tail, 2. Then tossing 2 coins means 2 raised to 2, that is equal to 4. Here tossing 3 coins. So head and tail are the outcomes. So 2 outcomes are there. Tossing 3 coins or a coin 3 times, both are equal. So 2 raised to 3, which is equal to 8. So outcomes raised to number of times. Here 2 outcomes, head and tail, 1 time, 2 raised to 1, 2 raised to 2, and 2 raised to 3, etc. So this set of all outcomes known as sample space. Now let us discuss rolling dice, throwing a dice. Let us discuss the outcomes. Sample space, throwing a dice. We know 1 dice, throwing 1 dice. This means sample space 1, 2, 3, 1, 2, 3, 4, 5, 6. These are the 6 possible outcomes. 1, 2, 3, 4, 5, 6. These are the 6 outcomes. So throwing a die, sample space are 1, 2, 3, 4, 5, 6. 6 outcomes. 6 outcomes. Throwing 2 dice. Throwing 2 die or a die 2 times. Which means throwing a die 2 times means sample space is equal to, we can write 1, first die is 1, second die is also 1, 1, 1, or 1, 2. First one, in first die 1, second die 2. Another possible event, then 1, 3, 1, 4, 1, 5, 1, 6. These are the outcomes. Then in second die it will come 2, then 1, 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, or 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. Then 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Then 5, 1, 5, 2, etc. 5, 6, also 6, 1, 6, 2, etc. 6, 6. These are the possible outcomes throwing 2 dice. First die 1 appear, second die also 1 appear. Here first die 1 appear, second die 2 appear. First die 1 appear, second die 3 appear. Like that. Here both dice are 3, 3. Here 4, 3. First die 4, second die 3. So these are the possible outcomes. Total number of outcomes are 36. So in a dice 1, 2, 3, 4, 5, 6. 6 outcomes are there. So throwing a die 1 time. So 6 raised to 1. That's we got 6. Here 36 outcomes are there. So a die 6 outcomes are there. throwing 2 times means 6 raised to 2. That is 36 outcomes are there. So these are the sample space of throwing 2 dice. So set of all experiments, all outcomes of an experiment is known as sample space. Next, probability. Let us study probability. Probability P of E. We represent probability of an event E is represented by P of E, which means probability of an event E, P of E, is defined as probability of an event E, P of E is equal to number of outcomes favorable to E divided by total number of possible outcomes of the experiment. Number of outcomes favorable to E divided by number of all possible outcomes of the experiment. For example, tossing a coin. Tossing a coin means the sample space are is equal to HT, head or tail. These are the 2 outcomes, head or tail. So let E be the event as getting head when tossing a coin. E be the event as getting a head. So P of E, probability of getting E. E be the event of getting head. So probability of E means probability of getting head. Probability of getting head. P of head is equal to, our formula is number of outcomes favorable to E divided by total number of possible outcomes of the experiment. This is the sample space. S is equal to HT. We need probability of E. E means getting head. That is probability of getting head. Here head, tail. Here one head. Only one head. We need getting head. So our favorable outcome is 1. Here only one head. That is our favorable outcomes is getting head. So here only one head. So favorable outcomes, number of favorable outcomes means 1. Only one head is there. So 1 divided by total number of all outcomes. How many outcomes are there? 1. So probability of getting head or probability of getting head or P of E or is equal to P of head, which is equal to 1 by 2. Let F be the event of getting tail. Getting a tail, which means probability of F, P of F is equal to probability of getting a tail, which is equal to how many tails are here? Only one tail. Total number of outcomes 1, 2. So 1 by 2. So probability of an event E is equal to number of outcomes favorable to E divided by number of all possible outcomes of the experiment. Now let us consider another example. Throwing a die. What are the outcomes? S is equal to throwing a die. Outcomes are 1, 2, 3, 4, 5, 6. These are the 6 outcomes of the experiment. Our question is that E be the event of getting a number greater than 2. Let E be the event of getting a number greater than 2. We have to find out probability of E. E be the event of getting a number greater than 2. So our formula is number of outcomes favorable to E divided by number of all possible outcomes of the experiment. Our question is probability of getting a number greater than 2. Probability of getting number greater than 2. So our sample space is 1, 2, 3, 4, 5, 6. So our sample space are 1, 2, 3, 4, 5, 6. Then our question is probability of a number greater than 2. So number greater than 2 means 3, 4, 5, 6. These are the numbers greater than 2. So we have to find probability of a number greater than 2. So our probability of E is equal to number of outcomes favorable to E divided by total number of outcomes. So number greater than 2 means these are the numbers 1, 2, 3, 4. 4 numbers are there. So favorable outcomes means number of favorable outcomes is 4 divided by total number of outcomes. That is 1, 2, 3, 4, 5, 6. 4 by 6. That is the answer. So probability of a number greater than 2 which is equal to 4 by 6. Another example. Tossing 2 coins. Sample space are head, 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 tail, tail, head, tail, tail. Probability of getting 2 heads. Probability of getting 2 heads which is equal to 2 heads. Our probability of getting 2 heads means in this experiment how many 2 heads are there? Here 2 head comes. Here only 1 heads. Here only 1 heads. Here no heads. So here only 2 heads comes. So probability of E is equal to number of outcomes favorable to E means only one time our 2 heads are coming. So 1 time divided by total number of outcomes. 1, 2, 3, 4. So 1 by 4. So probability of getting 2 heads is equal to 1 by 4. So probability of an event P of E is equal to number of outcomes favorable to E divided by number of all possible outcomes of the experiment.